Assalamu alaikum. Welcome to first online lecture for first year. As we are studying the unit number 3, measures of dispersion and skewness and kurtosis on page number 91. We have discussed mainly all the topics of measures of dispersion, and now we are going to start the topic skewness, which you can find on page number 129. But before going to skewness, let's discuss a curve, or let's revise the curve which we have studied in first chapter, symmetric curve, or it is also called the normal curve. This curve is found when you draw, or when you plot all the frequencies on the graph paper. So you get the curve like this bell-shaped curve, and this curve is called normal curve or symmetrical curve. In this curve, the mean, mode and median of the distribution is right in the center of the distribution, and these all are assumed to be equal. So whenever you get the curve like this bell-shaped curve, so you should take in your mind, or you should put in your mind, that this is symmetric curve, or this is also called normal curve. So what is skewness now? The lack of symmetry is called skewness. Means that anything which is not normal, which is not symmetrical, is called the skewness. That would be skewness. It would be different from anything different from this curve, or anything different from this shape is called skewness. Now, in a skewed distribution, the observations are not equally distributed. A measures of central tendency. Now, the distributions are not equally distributed around the measures of central tendency. Here you can see that these are mean, median, mode are the measures of central tendency, and the values are equally distributed to the left and also to the right of the side, and hence the shape on the both sides is also equal. So this means that the values are equally distributed to the left and to the right of the central tendency, or the measures of central tendency, or the average values. So but in skewness, these values are not equally distributed, and the number of observations to one side of the central value is greater than the other. Here the number of observations are assumed to be equal on left and right side, but in skewness or skewed distribution, the one side will be greater than another. Graphically, the tail of one side will be longer than the other, and here you can see that we have two types of skewness. One is positive skewness and the other one is negative skewness. And here in this shape you can see that the mean, median and mode values are not equal. This is showing mode, this is showing median, and this is the mean of the distribution. And also you can see that the left hand right hand tail is longer than left tail is very short, and this right tail is very longer than this left tail. So this is skewed. This type of graph, or this type of distribution, is called skewed distribution. And when the right hand side is longer than left hand side, it is called positively skewed or positive skewness. And now what is negative skewness? When the left tail is longer than the right tail. Here you can again see that the mean, median, mode are not equal, not on the same position, and moreover the left tail is longer than the right tail. So this type of distribution is called negatively skewed distribution. Actually, skewness is just showing the shape of the distribution. Now, how we can measure the skewness, or how we can find the skewness? So here we have measures of skewness. Three measures of skewness are there in your course. First one is the movement ratio. Second one is the Pearson's coefficient of skewness, and the third one is Boyle's coefficient of skewness. So the in movement ratio, this phi is used, phi 1 is used, or gamma 1 is used, and this gamma 1 is equal to under root beta 1. Now what is this beta 1? This B1 or beta 1 is actually the moment ratio, which we have studied before. And for revision, I have written here that first moment ratio is represented by B1, which is equal to M3 third moment square divided by second moment Q. Now this moments we have discussed in your class, last lecture of your class, and the student, those who were present, are familiar that that what are the moments and how we calculate these moments. We have discussed this in detail in the class, but again I will try to discuss it in this lecture. So this is the first. We have two types of moments which actually shows the shape of the distribution. So first moment ratio is B1, and second moment ratio is B2, which is equal to fourth moment divided by second moment square. So here gamma 1 is representing, again I will go to measures of skewness, and the moment ratio, in moment ratio method, gamma 1 is equal to under root B1. So B1 value is third moment square divided by second moment cube. So the range of this moment ratio is from minus infinity to plus infinity. We can have any value from minus infinity to plus infinity. The second measure is the Pearson's coefficient of skewness. In Pearson coefficient of skewness, mean and median is used. So first of all, for any given data you will find mean and median and standard deviation. This S is standard deviation, and then by putting the values in this coefficient you will get the result of skewness. Now for Pearson's coefficient, the range is from minus 3 to plus 3. So you can have the values from minus 3 to plus 3. And the Bole confidence interval, Bole's coefficient for skewness is here we use the quartiles: first quartile, third quartile, and second quartile. All three quartiles we are, first of all you will calculate first, second, and third quartile for any given distribution, and then you will put all the values in this formula, and this coefficient has range from minus 1 to plus 1. Okay, now interpretation of skewness. What does the answer shows? As I always tell you that in statistics, interpretation is very important. That what a given answer or what a given value shows about the distribution or about the data. So for all three formulas which we have discussed here, for all these three formulas, if the answer of skewness is 0, this means that the distribution is symmetric. The shape of the distribution is like this. There is no skewness. And if the answer of skewness is greater than 0, this means that the distribution is positively skewed. So here you can see that if skewness answer is greater than answer of the skewness, or of answer of any measure of skewness is greater than 0, then the shape is like this, positively skewed. And if the answer of skewness is less than 0, so it is negatively skewed. So by looking at the sign, you can decide whether it is positive or negatively skewed. And moments ratio I have already discussed. Now we have raw moments to mean moments. This is we have discussed in detail what are the mean moments, and we have also discussed about the raw moments. So if you have some raw moments, you can find these all formulas on page number 119. And if you have uh, in question some raw moments are given to you, so you can convert these raw moments into mean moments by using these all following formulas. So again you have to memorize these formulas. And now moments about origin or zero. Moments about origin or zero are actually the raw moments, and the formula is like m dash 1 is equal to summation x by n. M dash 2 second raw moment is equal to summation x square by n. Third raw moment is equal to summation x cube by n, and fourth raw moment is equal to summation x4 by n. So now the powers, you can say that for first moment power of x is 1, for second moment power of x is 2, for third moment power of x is 3, and for fourth moment power of x is 4. And you can find these all formulas on page number 123. Now this question will make you more clear, and according to your course, this question is also included in your course, and you can find this question number 3.26 part B on page number 143. Okay, now what's in the question? Suppose n is equal to 100, summation x is equal to 15, summation x square is equal to 97, summation x cube is equal to 33, and summation x4 is equal to 258. Find the moment ratio beta 1 and beta 2, or b1 or b2. Comment on the shape of the distribution on the basis of B1 only. Okay, now as I have told you before that the moments or raw moments about origin or zero are equal to this. So by using these all formulas, we get raw moments. Once we get raw moments like this, summation x is equal to 15 divided by n is 0.15, then 92 divided by 100 is 0.97, then 33 divided by 100 0.33, and similarly by putting fourth raw moment, 258 divided by 100 is 2.58. Now by using the conversion method, I have converted all the raw moments into mean moments, as I have discussed before, that raw moments into mean moments. So by using these all four formulas, we have converted raw moments into mean moments. So for first it is equal to 0. For second moment, as I have put all the values here, and then finally I get the value 0.9475. For third mean moment, the final value is minus 0.09975, and for fourth moment the final value is 2.51. So when you properly put the values in the formula, and by step when you solve the question, you get finally these answers. Then b1, as we have studied before, that b1 is equal to third mean moment square divided by second mean moment cube. So here I have put third mean moment value and taken the square, and then second mean movement value, which is this, and taken the cube. So here by putting the value, final answer is 0.011697, and the distribution is here negatively skewed. Why? Because it is the distribution is here positively skewed because it is greater than 0. So here this is misprinting. So distribution is positively skewed. Now the last topic for your chapter number 4 is kurtosis. Now what is kurtosis? And you can find this topic kurtosis on page number 136. So what is kurtosis? It is a Greek word which means the peakedness or the flatness of a graph of frequency distribution as compared to the normal curve. So what is the normal curve? As we have discussed this before, that this symmetrical curve is a normal curve in which the mean, median and mode values are equal and lies directly in the center of the exactly on the center of the distribution, and the curve is bell-shaped curve. So this curve is called normal or symmetric curve. So now this standard curve or this normal curve is a standard for us. So we will compare the peakedness or flatness of the other distributions with this normal curve. And what is kurtosis? This kurtosis measures the peakness or flatness of the curve. At first, in skewness, we have discussed about the spread of the curve, that in negatively skewed, the left hand side was longer, and in positively skewed, right hand side was longer. But here now we are going to study the peakness or the height, about the height of the curve or height of the distribution. So, types of kurtosis, there are mainly three types of kurtosis. Mesokurtic. Mesokurtic, if curve of the distribution is like normal curve, like this, normal curve. If the curve of the distribution is normal, it is called mesokurtic. And second one is platykurtic. If the curve of the distribution is flatter than the normal curve, it is called platykurtic. Now you can see the height of second one is less and it is much flatter than the normal curve. So it is called platykurtic. What is leptokurtic? When the height or peak is high, the distribution is high peaked than the normal distribution. Here you can see the normal distribution, and when you see the leptokurtic, it is more heighted or it is more peaked than the normal curve. So these are the three types of kurtosis: mesokurtic, platykurtic and leptokurtic. Now again, uh, similar as measure of skewness, kurtosis has also some measures. There are two measures of kurtosis. One is movement ratio method and the other one is percentile coefficient of kurtosis method. So first method is moment ratio method, and in moment ratio we are going to use now, for kurtosis we use second moment ratio, and for skewness we used first moment ratio. So now for kurtosis we are going to use second moment ratio, which is equal to fourth moment divided by second moment square. Now if this B2 second moment ratio will be equal to 3, this means that the curve is mesokurtic or the distribution is mesokurtic. If it is less than 3, the distribution is platykurtic, and if it is greater than 3, the distribution is leptokurtic. Then we have second measure, which is percentile coefficient of kurtosis, which is equal to quartile deviation, which we have discussed in detail, and percentile 90 minus percentile 10. So we have discussed these two measures, percentiles and quartile deviation, in detail in our class, in our regular classes. So by using the formulas of quartile deviation and percentiles. You will find the quartile deviation and percentile 90 and percentile 10, and after putting the values in this formula, you will get the value of coefficient or percentile coefficient. So now the cutoff value for percentile coefficient k is 0.263. So when it is equal to 0.263, the distribution is mesoquartic. When it is less than 0.63, the distribution is platyquartic, and when it is greater than 0.263, the distribution is leptoquartic. So this was the interpretation of kurtosis. Now the last question for your course is question number 3.27 part B, and this you can find on page number 144. From the following data, compute mean moments and coefficient of kurtosis. So this group data is given to you, in which classes and frequency are given to you. So you are familiar with this, that what is a group data? A group data in which group data is a data or is a table in which the classes and frequency are given to you. So now first of all, what is given in the question, that you have to find mean moments, and the formula for mean moment is for first mean moment and if it is group data, so it is summation f into x minus x bar power 1 for first moment power 1 divided by summation f. Now so you are familiar with this sign summation, which means sum. So whenever, I have told you before that whenever this summation is put with any formula, so you will this means that you have to take sum, you have to add the values of frequency and the values of this term. Now for second moment, mean moment, the power formula will be same, but the power will be square, and for third moment the power will be cubed, and the fourth moment the power will be 4, and the other formula is same. Now how to calculate them? For calculation, first of all you need to find the value of x bar, which is equal to, for group data, mean, or x bar is equal to summation fx divided by summation f. Now we have f, we have classes, we don't have x. First of all we are going to find x. What is x? X is the midpoints. So here we are going to find the midpoint. So first how we find the midpoint, this is you are very familiar with this. From very first chapter we are studying about the midpoints. So for midpoints you have to add both the class limits and divide it by 2. So by adding 9.3 and 9.7 and then dividing the answer by 2, we get 9.5. Then for second, 10, 10.5, 11, 11.5, 12, 12.5 and 13. So these are all the midpoints and these are represented by x. Now fx. So for fx you have to multiply the values of f with x. So here I have multiplied 2 by 9.5, so I get 19. 5 multiplied by 10, I get 50, and up to so on. And then because summation is written with fx, so I have taken the sum of this this column, and the sum is 6.65.5, 665.5, and the sum of frequency is 60. So 665.5 divided by 60 is equal to 11.1. Here I get mean, and after getting mean we have to subtract each value of x. We have to subtract mean from each value of x. So here 9.5 minus 11.1, which is equal to minus 1.6. Then 10 minus 11.5 minus 1.1, and up to so on all the values. Now starting from first moment, second and third. So for first moment I have to create a column which is equal to f into x minus x bar. So here I have created a column f into x minus x bar. What I have done here, multiplied these values again with the column of f, which is minus 1.6 multiplied by 2, which is equal to minus 3.2, and 1 minus 1.1 multiplied by 5 minus 5.5. 12 multiplied by minus 0.6, which is equal to minus 7.2, and up to so on. And then I have taken sum at the end, which is equal to minus 0.5 multiplied by divided by 60, which is equal to minus 0.008. Now here again for second moment, which is this. So for second moment I have again multiplied this column with these both columns, and I get this result. Then for cube I will multiply f into x minus x bar whole square by multiply by x into multiplied by x minus x bar, which will become cube, and after multiplying this cube again with x minus x bar column, we will get f into x minus x bar whole power 4. And by adding all these columns and putting the values one by one in these all formulas, you will get all the four moments. So now for moment ratio, first part is over, which was that find the mean moment. So here I have find all the mean moments, and the second part was coefficient of kurtosis. So for coefficient of kurtosis, as we have calculated moments, so we will use moment ratio method. So B2 is equal to fourth moment divided by second moment whole square. So fourth moment value was 0.8472. So here I have put 0.8472 divided by second moment ratio was 0.5375, so 0.5375 square, and by solving this we get 2.93. 2.93 is less than 3, and by using interpretation the distribution is plateautic. So students, this is all for today. Assignments will be given to you, and if you have any type of question, you can